Bismillahirrahmanirrahim. So in the last class, we discussed about the elastic moduli, okay? The first two elastic moduli, that is Young's modulus, that is for longitudinal, okay? For length expansion or change of length, okay? And then we discussed about bulk modulus, that is regarding the volume, right? And the third one that we couldn't discuss in details is modulus of rigidity, okay? Now, what is modulus of rigidity? Now, if you remember, we talked about shear stress and shear strain, right? In this change, what happens? The volume or the length does not change. The shape changes, right? Only the shape changes. That is shear stress and shear strain. So modulus of rigidity is basically the ratio of shear stress and shear strain. Okay, this is modulus of rigidity. Now we express it by N. Okay, we express it by N, shear stress divided by shear strain. Now, shear stress, what is shear stress? Stress is something we know that is similar to pressure. So it will be F divided by A, force divided by area. And what is the shear strain? The shear strain is the angle, if you remember, the theta, right? Okay, so from here, what I can write? N is equal to F by A theta. Okay, if you remember in the last class, I taught you this one, that if you consider this one as fraction, then F will be multiplied with 1 and A will be multiplied with theta. Okay, so F into 1 will be F, A into theta will be A theta. Okay, or else you can do it just the normal way that we do. Okay, F by A into this division, when it becomes into, the bottom fraction actually is reversed. Okay, so from there also you can write this, no problem. Acha, and what is the unit of it? Can anybody tell me what is the unit of it?
Is it a Newton
per meter square?
Always. Doesn't matter if it is modulus of rigidity or Young's modulus or bulk modulus. All of them will have the same unit. Why? Because all of them are the ratio of stress to strain. Stress is Newton per meter square, that is Pascal, that is the unit of Pascal, unit of pressure, and strain does not have any unit. Okay, so ultimately Newton per meter square, that is what is there. Okay, so this is modulus of rigidity, right? Okay. Then we have the next topic as Poisson's ratio. Okay, Poisson's ratio. Sadia, I have just uploaded yesterday's class. Okay, so I will give it in the group. Please watch it, inshallah.
Okay, sir.
So to understand the Poisson's ratio, we have to imagine something. Okay, let us say you have an extensible wire, a thick one. Okay, a thick one. Then
Poisson,
huh?
Poisson or position?
Poisson is the name of a scientist, Simon Poisson.
Oh.
Simon. হ্যাঁ Poisson's
ratio কেন করব?
সে একটা রেশিও অ্যাকচুয়ালি দিছে, সে তার দেয়া রেশিওটাকে আমরা তার নাম অনুসারে Poisson's রেশিও বলি। তুমি একটা রেশিও দাও, আমরা সাদিয়াস রেশিও বলবো, ঠিক আছে? ওকে ইনশাআল্লাহ। ওকে, তো তাইলে এখন এটার জন্য আমাদেরকে যেটা ইমাজিন করতে হবে, if we have a extensible wire, okay, now if you extend it, two things will change. What? Number one, the length will change. Along with that, the diameter will also change. Now, can you tell me, if I expand it, the length will increase, but the diameter will decrease, right? যখন আমরা একটা জিনিসকে টেনে এভাবে লম্বা করি তখন এটা আরো চিকন হয়ে যায়, তাই না? আর যখন চেপে বাট্টু করে ফেলি তখন এটা মোটা হয়ে যায়। তার মানে if the length is increasing, the diameter is decreasing, and if the length is decreasing, diameter is increasing, right? If one increases, another one decreases, right? So you can see that whenever we are expanding a wire, two strain is being generated. Number one, longitudinal strain, and the other one that is occurring due to the diameter change, that is lateral strain. I think this is new to you, right? Okay, so I will show it in the figure. The figure is already drawn on your book, but let me show it here. Let us say this is the original situation of the wire. Okay, now what we did, we hold it and we expanded it. What will happen? Definitely it will get narrow. It will not remain as wide as earlier, right? So it will become something like this. Okay, as we have expanded it, the diameter will have decreased, right? So let us talk about longitudinal strain first. Longitudinal strain. Now, what is a strain? Change per unit dimension. Let us say the amount of change that has occurred. Okay, this is the amount of change, right? This is the initial length, this is the final length. So final minus initial, that will give you the change. So this change divided by the initial length. Let us say the initial length is capital L, as we always represent. Okay, so this is longitudinal strain. Then we want to introduce the lateral strain. Okay, that is the change of diameter. Let us say this is the initial diameter. Okay, so initial diameter is represented by capital D, and then we have the change diameter, right? This is the change diameter. So what is the amount of change in diameter? The bigger one minus the smaller one, right? That will give us the change in diameter. Okay, let us say this one is D1, this one is D2. So what is the change? Change, let us represent the change by small d. Okay, then it will be D1 minus D2. Okay, but what we do normally, we represent the change by final minus the initial, right? Here this is the final and this is the initial. So if we write D2 minus D1, that will be negative. Okay, so I will talk to you about that. Okay, आगे एक जिनिस एकटू देखी है. So the change divided by the original. Okay, so that is lateral strain. Now Simon Poisson, he said something. He said that within elastic limit, these two are proportional to each other. Okay, longitudinal strain is proportional to the lateral strain. This is actually something that we can feel ourselves, right? The more we expand it, the more thinner it gets. Okay, let us say for now the change is L. Okay, if you extend it more and make the change 2L, that means you double the change. What will happen? This D will also become double. Okay, so this is what Simon Poisson said. According to him, longitudinal strain is proportional to lateral strain. Okay. Acha. We can either write it, lateral strain is proportional to the longitudinal. Let us write it the way he actually wrote. Okay. So now if I want to put an equal sign in between, definitely I will have to introduce a constant, and that constant he has introduced as sigma. This is a symbol sigma. This is the way to write. Okay, many people try to write it in this way. Okay, but if you try to write it in this way, it sometimes it becomes like 6. Okay, so it creates confusion. So write it the original way. Okay, do not write it this way, rather write it this way. Okay, this actually will show you that this is sigma. Okay, so this sigma will be equal to what now? This sigma will be equal to longitudinal strain. If you bring it on this side, then it will be lateral strain divided by longitudinal strain. So you can see there is a ratio. This ratio is called Poisson's ratio. Okay, and we express it by sigma. Is it okay? Can anybody
Yes.
tell me what is the unit of this Poisson's ratio?
No unit.
No
unit.
unit.
Excellent. No unit, because a strain does not have any unit. Strain does not have any unit. So no unit divided by no unit is equal to no unit, right? Okay. Now we will try to develop an equation for this sigma. Okay. Now lateral strain, we already got to know that it is d by b. Okay. And it is capital L divided by smaller divided by capital L. Okay, then according to what I told you already, multiply the upper one and the bottom one, so it will be small d into capital L and capital D into small l, d l. Okay, so this is the equation for calculating sigma. Anybody have any doubt?
No.
Okay. Now, equation number 7.14. I want you to take a look at it, okay? Here they have written sigma is equal to, they have put a minus in front of it. Yes, why it will be minus? I already gave you a little hint, right? Delta R divided by R naught. Okay, change divided by initial L. Change divided by initial. Okay, then from here we can write delta R into L naught, delta R into L naught, R naught into delta L. Okay, we can write this. Now, can anybody tell me why there is minus?
ছোট থেকে বড়টা মাইনাস করছে তাই।
যেটা ডি ইনিশিয়ালটা বড় ফাইনালটা থেকে।
একটু চিন্তা করো, আমি একটু আদানটা শেষ হলে কথা বলছি। I have written the case over here. You can see that when we are expanding, the length, final length is bigger because we're expanding. But we know that when we're expanding, the diameter gets smaller. Here actually R represents radius. We know that radius and diameter, they are related to each other. If the diameter is decreasing, radius will also decrease, right? So if it is getting thinner, then what will happen? The initial radius will be bigger, final radius will be smaller. So final minus the initial will give us a negative value, and here we will get a positive value. So negative divided by positive will give us a negative value. And if we're compressing, then R2 minus R1, this delta R will be positive, and this L2 minus L1, that is delta L, that will be negative. So positive divided by negative, I will still get a negative value. Okay, so that is why actually we put this minus over here, because we know that we are going to get some negative value already. Okay, so when you have put this minus here already, okay, what you need to do is, while calculating the delta R, you need to take just the difference. Okay, যেমন মনে করো R1 is 3, R2 is 1. As radius is decreasing, that means it is length is increasing. So L2 is, let us say, 5 and L1 is 3. Okay, so if I want to tell you to find out delta R, normally what you are supposed to do, R2 minus R1, you are supposed to write 1 minus 3 is equal to minus 2. But this minus is not required anymore, because I have already put a minus over here, right? So as I have already put a minus over here, from here you can just take the difference. What is the difference between 3 and 1? The difference is 2, so just write 2. And what is the difference between the length, delta L? That is also 2. Okay, so take just the difference. But in case you are not putting the minus over here, then you have to do it in this way, the final one minus the initial one. So please do not mix it. Okay, okay, inshallah. If you do it this way, that you have put a minus over here, and while calculating delta R, you are subtracting the initial one from the final one, then what will happen? Minus minus, it will become plus, right? So please be careful. Acha. Then we have the dimension and unit. I guess you all understand it. Okay. I think the second paragraph is a little bit important of dimension and unit. Okay. Kindly go through it. I will give you 1 minute, and if you have any doubt, you can ask me. No problem. I think this will be easier for you to understand. Okay. Because we know what is the case when it is a fraction. If the fraction is greater than 1, then what happens? We understand that the numerator is greater than the denominator. And if the fraction is equal to 1, then what will happen? The numerator and the denominator, they are equal. And if the fraction has a value less than 1, then the numerator is smaller than the denominator. I hope you understand, right? We all studied mathematics, right? Okay. So kindly go through it. I will give you 2 minutes. Okay. So did you go through? Did you understand?
Yes.
Okay. Alhamdulillah. So then on the next page, we have a topic that I have already explained to you. That is, steel is more elastic than rubber. Why it is so? Already I discussed, right? So kindly go through the paragraph and let me know if you have any doubt in the next class. Okay. Today I want to talk about
Okay.
Okay. So the last topic that I want to discuss today is the extended activity that you have on 415 page. Okay. Find expression for work done in stretching a wire. Definitely you are applying some force and you are stretching, you're causing some change, right? So you are doing some work. So what is the amount of work that you are doing? If you want to calculate it, you can. Okay. How we can do that? Okay. So let us say we want to calculate the work done to expand it from L equal to 0. That means the change is 0 to the change equal to the value of change that we have. Okay, for this amount of length change, I want to know what is the amount of work done. So at first, as we always do, we consider the work done for a small amount of length expansion. Okay, so as it is a small expansion, a small amount of work. Now, if I want to know the total amount of work, I need to integrate it. And the integration limit is going to be from L equal to 0 to L equal to L. So this integration differentiation will be balancing each other and it will become W. Okay, and we can replace the value of F. How we can replace the value of F? As we are seeing in expanding or stretching, we are talking about the change of length. So we need to take the equation or consider the equation of Young's modulus, that is longitudinal modulus. Okay. So what it was equal to? F, F then small l, no, capital L, FL by AL, right? This was the equation. From here, I will try to find out an expression for F. Then it will be YAL divided by capital L, right? So I will replace it here from 0 to L. It will be YAL DL. Okay. So you will see that all these three are constant. Young modulus for a particular material, it is constant. Area, the object you are not changing, so area is same. The original length, that is also fixed. What you can change is this one, the expansion. Okay, the more force you apply, the more expansion occurs, right? But that does not affect the original length, right? Original length, if it is 5 meter, then it will stay 5 meter until you change the object, right? Okay. So if this constant, I take it out of the integration part, then it will look like this. Okay, L, D, L. Now, can you do the differentiation? So the integration. Remember, it will be L square by 2. You have gone through so much of integration of similar kind. So do I need to show in details? If I need to show in details, then let me know. It is that
No.
okay, x to the power n plus 1 divided by n plus 1. Here the value of n is 1, so n plus 1 is 2, n plus 1 is 2. So after we replace the upper limit and the lower limit, then it will be, oh, this divided by 2, if I take it out, then it will come here and only L square will be there. So it will be L square minus 0 square. So L square minus 0 square is L square only. So y a L square divided by 2L. So this is the amount of work done, okay, in stretching. Okay. The next topic that we have, potential energy per unit volume at the bottom of the page. Okay, that one I will leave to you. Okay, because this is very simple. We know that the amount of work done is equal to the amount of potential energy that is stored in the body. But here we are not being asked to calculate only the potential energy, but the potential energy per unit volume. So whenever you are asked to calculate per unit volume, you know that you have to divide that amount by the volume, right? Okay, potential energy per unit volume, that means potential energy divided by the volume. So potential energy is equal to the work done. So work done divided by volume will give you the potential energy per unit volume. Anybody have any doubt?
No.
No? Okay. From here actually we can easily find it out, right? We have to actually divide by volume. Now what is volume? Volume is equal to area into length, right? So if you divide it by area into length, then you know that there will be some changes. So make those changes and let me know in the next class if you have any doubt on it. Clear? If you don't have any more doubt in these topics, then inshallah we'll be able to start flow of fluids, that is chapter 419 inshallah. Okay? ওকে তো বলো তাইলে ক্লাসটা শেষ করতে পারবো।
Okay, okay.
Okay, so kindly go through whatever we have discussed about and inform me through WhatsApp if you have any doubt or if you come across any doubt. Okay, assalamu alaikum wa rahmatullahi wa barakatuh.